Hey everybody, and welcome to this CNCF webinar on, an introduction to Crossplane. We're going to talk about everything from managed services to claims. My name is Chris Hansen. I work for a company called RXM. We're a cloud native consulting shop. We're going to talk about some of our expertise with Crossplane, hopefully get everybody started using the platform. All right, so let's talk about what Crossplane is. So primarily, Crossplane is an abstraction layer for cloud infrastructure orchestration. What that means is that we can essentially unify cloud APIs by using the Kubernetes API. For example, we can create objects within Kubernetes that are represented as Kubernetes resources, and then those things can get provisioned and kept in sync with some sort of cloud backend. It acts as a low-code or no-code framework for building cloud-native control planes so that you can use your Kubernetes cluster to deploy things in the public clouds and private clouds and hybrid cloud infrastructure, leveraging the same concepts that we've used for a long time with infrastructure as code, because of course Kubernetes objects are manifests, right? And we can check those things into Git, just like we would check in to get the files from other types of infrastructure provisioning systems. So think about like Ansible playbooks, right? Those are written in YAML. You've got Terraform configuration files, right? Those things are all checkable into Git and help us with GitOps workflows. And Crossplane is no different because we're using manifests in Kubernetes. And in reality, it's an extensible backend to really manage anything with an API. So that API is essentially represented as Kubernetes custom resources. There was an interesting project that one of their folks did where they integrated Crossplane with the Domino's API and like ordered pizza from Domino's. That project's still out there, so check it out on GitHub. Let's talk about why we would want to use Crossplane as opposed to some of these other tools. So first off, Crossplane provides active state enforcement. So unlike these other infrastructure as code tools like the aforementioned Ansible, Terraform, OpenTofu, those types, Crossplane uses the notion of the Kubernetes control loop to keep things in sync. So it's doing active state enforcement, whereas opposed to something like Ansible, Terraform, on their own, right? Ansible is an executable, and you can run it on a schedule, but that's different from something like Crossplane that's actually using the control loop methodology or functionality from Kubernetes and keeping external resources in sync, like it does with normal Kubernetes objects, right? Two would be the ability to unify a control plane, right? Instead of a bunch of back-end cloud APIs, we can use Kubernetes API to rule them all. This simplifies things like access controls to just the Kubernetes API. We don't have to give users access to both Kubernetes for their Kubernetes resources and then the cloud backends to create and manage their cloud resources. We can just use the Kubernetes API and allow them to create both things. As well, it's cloud agnostic. There are ways to create cloud resources with Kubernetes in the various clouds. Amazon Arc, for example, comes to mind. Or sorry, ACK, I should say. But that's Amazon specific, something that you can only use within Amazon. And each one of the three clouds, Google Cloud, Microsoft, AWS, have their own way of doing this. But then you're also using that cloud provider's way of doing things, right? So with Crossplane, we're cloud agnostic. And so abstracting away the details of whatever cloud we're connecting to makes using multi-cloud much easier, right? I can define services, I can define Crossplane resources in a cloud agnostic way within Crossplane, and then allow the machinery of Crossplane to go and reach out to whatever cloud or clouds I'm working with and deploy those things the way that the cloud wants them deployed, but without exposing those things to the user. So this also allows a user to move their workload from one cloud to another with little to zero modification. And of course, because we're talking about Kubernetes, right? Kubernetes has a large ecosystem, and this enables things like GitOps workflows for both Kubernetes workloads as well as cloud resources, right? We've got all the same tooling that we're using. If you're using Argo CD, you can still use that with this. If you're using any other systems that work with Kubernetes, because these Crossplane resources become Kubernetes resources, you can use it with Crossplane as well. And then it also allows platform operators to build opinionated control planes that allows them to offer essentially APIs that are tailored to the unique orchestration needs of the organization, right? So our example here says, let's say we have a set of immutable IAM permissions. So we're only going to allow certain permissions against the cloud resources, and that's something that we don't change regardless of what we're deploying. But that permissions role can be attached, let's say, to an AWS EC2 instance. And that AWS EC2 instance can be whatever size or flavor that the user wants, right? So we've injected our opinion. That opinion is we only grant a certain role to that instance, an infrastructure role or a node role, but the user has some flexibility to change the size of their instance so that that instance can support the workload, CPU and memory disk requirements that the workload needs. Now, how does this all work? So once we've got Crossplane installed in a Kubernetes cluster, we essentially extend the Kubernetes API with Crossplane custom resource definitions. These extensions represent cloud provider specific things like databases, virtual machines, storage, right? So that we can use all of the services of the cloud as a Kubernetes resource. And so to deploy one of those things, let's say we want to deploy an S3 bucket, really any object storage bucket in any of the clouds, right? We declare a custom resource that specifies details like the size, the type, the region, other configurations that are specific to that resource that we want to create, and then we deploy that thing. Now there is an opportunity to abstract away some of this as well. For example, like the region, right? The region in Google Cloud, the way that the region string is formulated is going to be different from Azure. It's going to be different from Amazon, right? So we have some opportunities here to abstract that away and allow a user to specify something generic, like just US East or US West or Asia Pac or something, right? And then that gets translated into the string and the format that the cloud wants without the user having to know that information, and we'll of course explore that in this session. And then of course the core of Crossplane reconciles the actual state of the cloud resource with the desired state that you've declared in that custom resource. And so if that custom resource isn't running, Crossplane will run it. If that if that cloud resource crashes, Crossplane runs it again, right? Replaces it or starts it back up again. If there's an accidental deletion of some sort of object, right? We do that reconciliation loop and we replace or restart the object with a new one, and it acts exactly like Kubernetes does for internal resources. We're just hooking into cloud APIs and providing that reconciliation loop. So how does Crossplane integrate with these clouds? In Crossplane, we use what's called a provider. A provider extends the Crossplane core of Crossplane with cloud provider specific CRDs. This makes sense because I may not use every API in a given cloud, and or I may not use a particular cloud at all, right? So if I'm not going to use Google Cloud, for example, then I don't need to deploy those APIs. And so therefore I wouldn't deploy a Google Cloud provider, right? Same thing goes with APIs within a given cloud. There are hundreds of APIs that are available from a given cloud provider. While we could deploy something monolithic, we can also deploy something more granular to just create the specific custom resource definitions or APIs that are associated with the services that we want to use, right? For example, EC2 or S3 or Elastic MapReduce, whatever those things might be. So this will map a given Kubernetes API to an external API. Right? For example, here on our slide, we say a bucket Kubernetes resource that represents an Amazon or AWS S3 bucket. We'll map the Kubernetes custom resource to the Cloud API. But if I'm not going to use, let's say, Amazon RDS, then I wouldn't deploy a provider that would integrate with the RDS APIs. In other words, I wouldn't really offer them in my Kubernetes cluster because I'm not going to use them. So this kind of modular approach allows Crossplane and platform engineers to deploy providers that they're going to use and allow their users to consume those cloud APIs through custom resource definitions that represent these cloud APIs, and then omit the things that they're not going to use or that they don't want users to have access to. How we do that is essentially through pods, right? Each provider resource, or I would say kind of like a sub-resource, right, is run as a pod. So, for example, there's an S3, AWS S3 provider. There's an EC2 provider. Those things would be separate pods running in the Kubernetes cluster, right? So if we're not running a given pod for a given set of APIs, then there won't be CRDs. You can see in this diagram what happens is when we deploy the AWS provider, it registers those CRDs with the Kubernetes API. And so once those CRDs are available, they can be consumed by a custom resource. So if we're not going to use RDS, for example, we just don't deploy the AWS RDS provider, and we don't offer RDS as something that that is an API that we expose on our Kubernetes cluster. There are a number of providers that exist in both the Upbound marketplace as well as the open source. This was actually just announced, the open source GitHub registry, because these things are OCI images in the end. So a good place to find this stuff, though, is to go to the Upbound marketplace. And then, of course, if you can't find something that integrates with your API of choice, you can author one, and that goes back to the Domino's one I was talking about before, right? That was just a custom provider that one of the folks from Upbound deployed on their Kubernetes cluster and then integrated with the Domino's API, right? So if you have APIs that are not covered by a particular provider, you can author your own custom provider and then deploy that onto your Kubernetes cluster. So as you can see in the diagram, going back to the diagram here, right, the AWS provider registers a bunch of AWS CRDs. Let's say in this case, that S3 provider will register CRDs related to S3, and then we would create a custom resource associated with the bucket. And so once we create that custom resource that is of type bucket, the AWS provider reads the desired state of that custom resource, communicates with the backend, and then creates our S3 bucket. And so that allows us to deploy and manage our cloud resources through this integration with these providers. Now, these custom resources have a special name within Crossplane, and that is known as managed resources. Makes sense, right? Because Crossplane is managing them, and so they're aptly named. When we see a managed resource within Crossplane, that managed resource represents some instance of an external resource, whether it's a S3 bucket, Azure database, GCP Bigtable, Kubernetes namespace, OpenStack block storage, those sorts of things. Because we can, it's not just cloud infrastructure that we're talking about here, but also Kubernetes things, right? Sort of a way of meta managing Kubernetes objects, right? Because these managed resources are really kind of building blocks to much larger services, they're considered low-level objects in Crossplane, right? If I want to deploy something useful in a lot of cases, then I will need multiple managed resources. In our example here, we have an EMR cluster So Elastic Map Reduced Cluster in AWS. Of course, that needs a VPC for networking, right? It's going to need S3 for storage, for data, both reads and writes, right? S3 is sort of the stand-in for HDFS in that case. And so I'm going to have to deploy multiple managed resources in order to create something useful. And so later on, we're going to look at a demo here first, but later on we're going to see how we can kind of group up managed resources in a single offering, so that that useful thing, whatever it might be, can be defined a little bit more abstractly, and we can also put some more controls in place. But for now, let's take a look at what managed resources look like in a Kubernetes cluster. So we're going to deploy something kind of simple here, right? Just for kind of learning purposes, right? So what's the building block of the cloud? Well, it's like a virtual machine, right? So let's say we just want to deploy that. Well, depending on what cloud you're in, you're going to need a certain number of managed resources. But you're always going to need compute, storage, and networking. In AWS, this is VPC, right? These are subnets, internet gateways, so we can get traffic to the virtual machine. This is a routing table. You've got security groups for your firewall. You need a key pair in order to connect to that virtual machine, and then you need the actual instance itself, right? That's a number of a number of MRs that need to be created in order to just create just the basic building block of the cloud, which is a virtual machine, right? So let's do that. First, let's take a look at one of those things. Let me list what I have here. And you can see I have exactly that, right? I've got VPC, right? I've got a subnet, security group, I've got a route table, I've got a key internet gateway, and then I've got a key pair for the VM, and then I have a VM itself. Let's just count the VPC as an example. Right, so going past all the metadata and everything, we look at the specification, right? These are the things that we need to specify in order to create the VPC, right? So we're going to have a CIDR, right? We're going to enable DNS support in this case, the DNS host names. We're going to put in a particular region, right? And then we can even have metadata, so tags and a name for the object. This is just a small number of things, right? If you think about a Terraform configuration or just the AWS CLI, for example, right? Let's say I'm going to create a VPC with the AWS CLI, right? There's a number of flags when I go to create that VPC that I need to specify. Well, it just so happens that they're similar to what we're seeing here, right? Whether or not we want a certain CIDR block, we have to specify what that is. We have to put what region it is, right? That's the -- region flag, etc. So if you've used something like Terraform or the AWS CLI or some other tool like CloudFormation or something to create a resource within the Amazon cloud, this will feel familiar because the keys and values that you're going to see within the managed resource are going to be similar to all the things you have to specify in any other tool, right? We're just doing it in a custom resource called VPC that has been created by the provider. So, for example, if I kubectl get CRDs, it's going to be a long list, but you can see I have pre-deployed the EC2 provider, right? And so there's lots of things in here just related to VPC, VPN gateways, right? So we've got subnets, security groups, right? Routes, things like that. Each one of these things is something that I can invoke, and so I'm going to invoke the VPC CRD, and so that's what my kind is, right? So VPCs. And so let's do that. right? So there we go. This allows me to create a VPC. I can list my VPC. Now I can see here that it's not ready yet, right? This is going to take a moment for Kubernetes reconciliation to kick in, right? This is an eventual consistency model. And so my VPC won't be ready until the provider can reach out to AWS, provision the VPC, and that will take more than a moment for me to do. Let's wait for a second. And now that has synced up. And we have an actual VPC ID that's associated with it, which means that that VPC now exists in the cloud. It has been reconciled, right? The state of the cloud has been reconciled with my desired state. In other words, create a VPC. And so now my VPC is ready to be used. But again, it's just one thing. It's just one piece of the larger puzzle, right? I have to build on top of that with other things. So now let's cat my subnet, right? So within the subnet, I've got, again, a number of things that I need to specify. What availability zone that subnet's going to be in, the CIDR block, right, which is a part of that /16, right, is this /24, so it has to be a subset of that VPC. The region. Now, how do I connect the subnet to the VPC? Well, if we look under this VPC ID selector, we're using a match label. So like anything else in Kubernetes that uses selectors, that's what we're going to do here, right? We've got a key value pair, right? lab.rxm.io/name, and we've got the Crossplane webinar VPC as the value. So this is going to go run a query and find a VPC out of all my VPCs that has that label. So if I go back here and say get VPC, right? There's my label. There's my key value pair. It will go and run that query for that key value pair. And of course, this will match. And so it will know that this subnet is associated with that VPC and create the subnet in the cloud in that VPC, right? So let's do that. All right, so same thing's going to happen here. If I get my VPCs, or sorry, my subnets, right? All right, so a little faster sync there, but we do have to wait for that to sync. And I can move on to the next thing, right? What's the next thing we would create? Internet gateway, a route table, those sorts of things, right? So let's do one more real quick. Okay, so let me clear my screen. We'll do another one. So if I cat, for example, the internet gateway, right? So we've got internet gateway that, again, we're going to set up in our US West 1 region. And again, we're using that match labels to connect to the VPC. If we look at, for example, the route table, then same thing here, right? We want to associate it with the VPC that we created before, and then also this internet gateway that we're going to create up here. All right, so let's go ahead and create those. Now it doesn't really matter what order I do these in, but I'm going to do them internet gateway and route table. And it helps if I can spell. Okay, so now I've got a number of resources that I've created. So if I want to list all of them rather than comma separating kubectl get, VPC, subnet, etc., you can use kubectl get managed. Now this can be kind of a dangerous command if you have a lot of managed resources. Obviously I'm doing a demo here in a small cluster, and so I don't have a ton of those, but oftentimes you want to filter this with some filtering. But you can see that I've got my VPC, my subnet, internet gateway, route table. and I'm building my way towards uh, right deploying all this infrastructure so that I can get my VM. Um, if we list what I have left, right, I still have to create the security group. I still need to create a key pair for my virtual machine, and then I can deploy my virtual machine. But as I said, it doesn't really matter what order I do these in. It's just to keep things moving. I'm just going to kubectl apply and do everything here. And it should apply all of my YAML files. And of course, the things that I've already deployed say unchanged, because just like any other Kubernetes resource, right, they're idempotent and won't update or change based on my my apply command. So let's do it again. kubectl managed, and see if I have everything set up. Right. So now I have everything I need. I've got the subnet, the key pair, the route table, etc., and I have a virtual machine that's deployed. So most of the stuff was networking, right? The compute is really handled by the instance. Just turns out that also the instance in AWS comes with a default amount of disk. So if I cat the VM real quick, you can see that there are some things specified in here. For example, I've got the AMI that I'm going to be using for, this is like the Ubuntu 2204 AMI. I've got the size. I've got the key pair that I've created, which of course is this guy here. And then I've got to associate it with a subnet, so it's got that match label for the subnet. And a lot of the other things are just defaults. So the disk is going to have is just like an 8 gig GP3 disk, right? But of course I can customize that if I want to. So how do I reach my VM from here, right? The whole point is to be able to reach that virtual machine or use it, right? So I've got a command here that is SSH. All right, so I previously created this key pair, and of course I used it as part of the Crossplane webinar key pair. So I'm just going to get the instance, and I'm going to get the public IP. Matter of fact, let's run this standalone, and you can see that part of the status of an object, just like anything else in Kubernetes, is details about it that come from what's being reported, right? What's being synced. And so if I traverse the status field, look at the provider details, specifically the public IP, I have a public IP here. And so now I'll rerun that command, with my SSH command. So I'm going to SSH using that identity file and be the user Ubuntu. It's going to ask me add it to the list of known hosts, and we should connect, right? Now what you notice is that the prompts look very similar, right? This isn't the original control plane machine that I was using. You can see that the host name of the new machine is different. So it's 172.31.137. So different machine, right? If I did kubectl on here, get pod, for example, kubectl is not installed in this. It's a completely different machine, right? So now I can go about using my virtual machine, right? All right. So that allows me to deploy a bunch of managed resources that essentially are all built up to allow me to deploy a virtual machine. You can take these same concepts and apply them to any other services in the cloud, right? What are all the building blocks? What are all the things that you need in order to deploy a service, right? If it's a relational database, right? You need a network, right? You need storage. You're going to have all these options that you're going to have to specify. If it's uh, some sort of machine learning platform, if it's a Kubernetes cluster, you can deploy a GKE cluster or an EKS cluster from Crossplane, right? What are all the things? There's a lot more things for something like that, right? And we'll have to specify all of them and link them all together, and then we've got a full set of resources we can use in the cloud deployed from the Kubernetes cluster. Now, the problem with managed resources is that they're very provider specific, right? I had to specify things like the region, and I had to do it in the specific AWS style, right? I had to know things like the AMIs, or the AMI for the VM, right? Those specific things, I have to have a lot of knowledge about AWS to do them, right? So what if I wanted to, and of course, another problem is that they're all disparate things, right? Like, how do I know what I need, right? I know that I need a subnet and a VPC and internet gateway and route tables and everything because I know AWS things. But what if I don't? Then there's a learning curve, and then there's also no way to really prevent somebody from using whatever settings they want. I just created a security group with whatever rules I wanted, right? There's no way for us to inject any sort of opinion in there. So it's really up to the platform team to think about what they want to offer and then understand how to create the managed resources associated with that service offering. But we probably want to offer it to our users as something more whole or holistic, and also something that can be more opinionated. And that's really where Crossplane compositions come in, right? We can think of a composition as a template for a collection of managed resources that can be put together as a solution or service offering, so that multiple managed resources can be deployed and managed together at the same time, right? As we saw, a VM requires a storage resource, it requires a network resource, but those are all disparate things in terms of managed resources. But all three of those things can be defined in a single composition so that we can deploy those things together. In our example here on this slide, we have two such offerings that are kind of the equivalent, right, in two different clouds, right? So we've got a AWS service that represents Kubernetes. And then we have a GCP set of managed resources that represent a Kubernetes service using GKE, right? So we've got EKS, ECR, we've got the security groups, the firewall, etc. in AWS. You've got GKE, you've got the GCR for the registry, you've got the VPC settings, the firewall for GCP, and then you've got the IAM things that you need for both GCP and or AWS. And so if we put all those things together, we can then create a more cohesive set of managed resources that represent a Kubernetes service, right? And you'll notice one thing right away is we've got two Kubernetes services. They're running in different clouds, but they're essentially the equivalent, right? Because if a user just wants to deploy Kubernetes, they may want it in Google Cloud, they may want it in Amazon, they may want it in Azure, and we can create a given set of managed resources that represent that type of Kubernetes service in a given cloud, right? By using all the appropriate MRs. These also allow us to enforce standards as well as certain settings across deployments, where we can define fixed or default settings for each one of the managed resources inside that composition, and define fields that users can customize and change. This is where the opinion comes in, right? So our example here is a VM that has a fixed compute and network, but a user-defined storage size, right? So we can, within our compositions, set defaults, set policy-based opinions within them, but then have enough flexibility for users to deploy, let's say, a virtual machine of a certain size or a Kubernetes cluster of a certain size or a certain type. That is part of that service offering. Now, a composition of itself in and of itself does not create any managed resources. This is just a template, right? You can think of a composition kind of like a Helm chart, right? So Helm chart on its own just defines a bunch of resources. In the case of the Helm chart, it's just, a deployment, a service, maybe a service account, and network policy and stuff like that, right? But unless you Helm install it, there's nothing running on the cluster. A Crossplane composition is the same thing. It's just a template. Now, in this case, we do register the composition as a Crossplane resource, but it doesn't mean it when you create the composition it deploys managed resources. No, it's just a way for us to create a consumable template for users to deploy, and we're going to look at how we deploy it coming up here shortly. Now, at the core of compositions are composition functions. Much like providers, composition functions are pods that will run in Kubernetes, and we'll need to install them as well. And they're essentially gRPC servers that are called by the Crossplane core pods to implement resource generation, right? Render templates, as well as patch field values. Because if we're going to create resources within a given cloud, we're probably going to want to customize them in some ways. Right? We just talked about like some things are going to be default, some things we're going to allow users to supply values for. And so composition functions can do all those things. The most widely used one, arguably, is the function patch and transform. This was core functionality in Crossplane until Crossplane kind of decoupled it from the core of Crossplane and allowed functions to be used within composition pipelines. And so the patch and transform function is a way for us to provide patches, right? So we can take a value from one resource and then apply it to another. This can be an existing managed resource, right? If we're retrieving values from somewhere else, oftentimes it's a value from a user, right? An input variable, so to speak, from a user. So you can think of it as a way for us to, very much like a values file in Helm, hydrates variables within Helm charts, right? We're going to take that same input in a different way, of course, but take that same input and then patch it onto the existing defaults of what is set in the composition, right? So if the composition is made up of a bunch of managed resources, like a Kubernetes cluster of X number of nodes in a node group, right? Maybe X is actually held by 3 nodes, but the user wants to deploy 10 nodes in their node group, right? We're just going to patch over the number 3 with 10 from the user input, or in this case on the left-hand side of the example, the region. The other, I don't want to say function, but the other thing that the function patch and transform does is allow us to modify values before applying a patch. This is where abstraction comes in, because we can take input from a user that's generic, right? So on the right side of this example, we see size equals large. We can transform that into something that's meaningful to the cloud. So that way we can abstract away the low level or the back end details of a given cloud provider or API into something more generic that the user doesn't have to learn, right? This goes back to one of the Kubernetes tenets, which is the platform should always do the heavy lifting, right? It should always be easy. Oftentimes it's supposed to be easy for the application, but in this case it's easy for the user, right, to supply values in a generic way. We'll transform them on the platform side into something that's meaningful to the low-level managed resources as they get deployed and or updated within the provider of choice, the cloud provider of choice. And so patch and transform is one of the ways that we do that. Now there are other composition functions that exist. You can use Go templates. There's a queue composition function, which means that if you have a choice in terms of like your DSL, and you want to use Go templates, you want to use queue, you want to use something else, you can, because this now is pluggable, right? Whereas before, when patch and transform was like core to Crossplane, it wasn't pluggable. Now it's very flexible and You can plug in other engines if you want, but the function patch and transform remains a very powerful way to do things. And so this sort of begs the question, well, how do we take input from users, right? Because I talked about the values.yaml. Well, what's the equivalent there? Well, this is what's known as a claim. So the primary way that developers or end users interact with Crossplane is through what's called a claim. Claims are an abstract way of invoking a composition made up of managed resources or Go templates or something like that that will deploy resources within a cloud, right? So maybe if my composition is for DynamoDB, it might just be the table name, the hash keys, and the global index name, and that's it. So we want to create a way for users to give us potentially generic input and then convert that, and right, patch and transform lets us do that. How we do that is through what's called a composite resource definition. This is very similar to a CRD, but the composite resource definition is a CRD that, as a platform engineer, we define, and then we define what the input variables are. It's kind of like the schema in a Helm chart, right? We have the actual schema.json file in a lot of Helm charts that define what types and things that will be accepted as values coming from the values.yaml. This is the same thing, or really like any schema, like any other Kubernetes standard CRD. But the idea is that this is our opportunity when we define the composite resource definition. We're defining APIs, and so we can define what values we will accept. This is where we define those abstractions, right? In our example here, right? The large can be T3A large in AWS or C4A standard 2 in the Google Cloud, especially if we are doing multi-cloud, where we're going to want to allow users to define generic details about the thing that they're deploying and then convert those into cloud provider specific requirements under the covers, right? We never want to expose that to the users because we want to just allow them to provide something generic. And so that claim then really essentially abstractly represents a set of managed resources deployed from a composition template as essentially a single abstract Kubernetes object. And it exists in the user's namespace. So one of the things that Crossplane does is compositions, the managed resources, those types of things are not specific to the user's namespace. Just the claim is, right? So the user is really abstracted away from all these low-level details because that's the only thing they're going to see is that claim. And so all the status information that gets reported from these low-level things like managed resources, etc., makes its way up to the claim and gives that claim status information, like whether or not the thing that we want is ready, right? If it's done being deployed. Now, one last piece of the puzzle includes what's called composite resources. Whenever a user creates a claim, that will create a composite resource. Much like a claim, composite resource represents a set of managed resources as a single Kubernetes object. And so this is, again, to draw that parallel, much like multiple Helm releases use the same Helm chart. Multiple unique composite resources can use the same composition. And so the composite resources fill out the template, create the managed resources customized by the user in the backend cloud. You'll see these things tied together, right? The user will create the claim. The claim is bound by the API defined by the XRD, right? All the input variables, whether they're required, whether they're defaults, that sort of thing. We will then create a composite resources that represents essentially all of the hydrated values from the claim, and then that gets deployed as managed resources, and those managed resources then get synced with the backend cloud APIs, and we have whatever the thing is that we're deploying, in this case, either a EKS cluster when all the things associated with it, or a GKE cluster and all the things associated with it in the Google Cloud. And so from the user perspective, this is very simple because all they have to know is what details to specify in their claim, which are going to be generic, like large, maybe a generic region or whatever it might be. And then again, the platform does the heavy lifting of translating that into the cloud provider specific things that need to be specified when those resources are deployed in the cloud. Okay, so let's take a look at doing that, right? The act of creating all the managed resources before was kind of heavyweight and disconnected, but if we create a composition and the associated API for it, then we can deploy a set of managed resources just with a very simple claim object. The first thing we need to do in order to deploy our composition is we need to deploy the function. So if I take a look at the function here, this just comes from the Upbound Marketplace. This is the function patch and transform that gets deployed as an OCI image. Really all I need to do is kubectl apply -f function.yaml. That will deploy a pod, and that pod will allow me to essentially what happens is it's going to the Crossplane core, because I'm going to call a patch in my composition. It's going to call this pod and say perform the patch that I need you to do, and then the function patch and transform will do its thing and send back the modified managed resources with the patches, and then they can be deployed via the provider. So let's look at that composition, and I'll scroll up to the top here. So it's really just a big list of resources, right? So the function it's referring to is the function patch and transform. Of course, that's the one we're going to be using. Now, most of these are just static values, but remember, we created a bunch of managed resources before standalone, right? So now we have a VPC, we've got the subnet, we've got the internet gateway here, we've got the route table, right? Everything else we used before, security group, the key pair, and then of course the instance. Right now, in this case, the instance has an extra section, and this is the patches section. This is what we're going to use the patch and transform function for. So we're going to take input, as it says from the composite resource, or basically upstream, and we're going to patch it downstream to the managed resources. The managed resource, basically the instance, right? So you can see how it gets mapped. Spec.size, which is going to be the input that we're taking from the composite, is going to be patched to spec for provider instance type. Now this is a individual patch that we're doing on a single object, right? It's associated with this instance object. You can also do patches that are a little bit more global. We're not going to cover that here, right? So spec for provider instance type, right? So spec for provider instance type, right? So our default is T3A nano, and so we want to be able to replace that. Now in this case, we're also going to use a transform as part of this patch, because we don't want users to have to specify the AWS specific instance type. We don't want them to have to know that thing, right? We probably would, abstract away as much of the AWS specific things as we could, right? This is just an example of one thing. So the transform is going to take an input of small, medium, or large, and it's going to convert that to nano, micro, or small, right? I'm using small sizes just so we don't run up our AWS bill here, but you can see you can get the idea, right? A user can say large and then get a different instance than the default. In order to allow a user to pass this in, we need to define a schema that they can do that with. And so if I cat the XRD, this is where we define our APIs. So the composite resource is going to have the kind of VM, and the claim will use the VM claim kind. And you'll see the claim here in a moment. And we have a very simple schema here that has a single value called size, right? So again, we're taking in spec.size from the claim, right? In our composition, that's what we defined up here, right? Was spec.size. And so that is going to default to the small value if a user doesn't provide any input. But we're only going to accept the three values, right? It's going to be an enumerated list, so small, medium, or large. We can't just put in blah or whatever and it will work, right? Because it has to be mapped up here to those maps, right? That set of maps. You can do like regex maps and stuff like that. This is just a a simple string match. Right. So now we're allowing the user to input a parameter called size and then give us one of three values in their claim, right? Defined in our API schema. So let's look at the claim. And it is very simple, right? It's got spec.size, and we're going to set that to medium just so it's not the default, right? Our default should be a nano, and our our nano, but our medium is going to be micro, right? So we'll deploy a micro instead of a nano. And then this other part, this composition selector, uses a match label set to provider AWS. This is a way that users can differentiate between the different compositions, right? So let's say I had an AWS VM, or I had a Google Cloud one, or I had an Azure one. I can put a label, and if I just do head on my composition, you can see that there's a label here that's set to provider AWS, right? So this gives the user choice. If they're going to deploy their VM in AWS, they would use provider AWS. If it's GCP, we could say provider GCP and that composition, Azure and the Azure composition, and that allows us to give the user the choice of which cloud they're going to deploy to, right? We just do that through a simple label selector, right? So we've got the function deployed. Reminder on what files we have here. The next thing we'll do is go ahead and deploy the XRD, the custom API that we're going to deploy, right? So now if we list our, let's just do CRDs, I guess, grep for VM, kube, CRDs, git. Helps if I do git. Right, so there's our two APIs, VM claims and VMs. And right now I have APIs that have registered. I can list my XRDs as well, kubectl get XRD. And you can see that the API has been established and it's offered, which means that I'm ready to go, right? It may take a minute for a custom resource to register itself with Kubernetes API. So in this case, it is now ready to go. Right. So next step would be to create the composition. Right. So my composition is now applied. Again, I can list that composition, and it is linked to my VM's API. Right. So my API version is the VM kind, and the API version is example.com v1 alpha 1, which is what we've offered, right, via our example.com API. And so now we're ready to go, right? This is all done by the platform team, right? We set all this up ahead of time, and now we've given this service offering to our users. And so all I have to do from the user side, let's say, was apply my claim. Right, so now my claim is applied. I've specified a virtual machine that I want to deploy in the AWS cloud. I want it to be the medium size, and that's all I care about, right? I just want a VM. I don't care about all the nitty-gritty details. So if I VM claim, right? So all right, you can see that it's synced, but it's not ready, which means that all the managed resources that deploy with my composition are not yet deployed yet. Now, from the user's perspective, this is all I can see, right? From the backend perspective, from like the platform perspective, if I have the permissions, normally a normal user would not. I could use kubectl get managed and see those things being deployed at the low level. what we want is that the all of the status information that's being collected for all these managed resources is to surface its way all the way up to the claim. So if let's clear this. Right. So in this case, I've got events that say whether or not the thing is ready. Right. I've got low-level status conditions, things like if it's synced, if it's ready, and any sort of events associated with it being ready. You can see in the events that it took a while. Right. It was 94 seconds where we're waiting for the composite resource to become ready. And eventually it was, or eventually it is. So if I just do kubectl get VM, right, now we know the VM is deployed and it's ready because we've got synced and ready both set to true. So if I use my kubectl command again to get the status information, again I will break this command out of the nested SSH just to show it, right? That I'm retrieving that from my instance, right? I've got an IP address for that instance. And so if I try and SSH again, right, there it is, and I'm connected to the VM. Again, from the user's perspective, it's much simpler, right? All they had to do was specify something very abstract, like what size they wanted. And all of those things that normally I had to deploy manually were just done for me as the user. And then I've also protected the user from having to know cloud-specific things as well as enforced policies, right? Because the security group that I created for the VM was a specific security group. I didn't give the user any choice there, right? I gave them the ability to SSH to it, but that was it, right? There's not a bunch of ports that are just wide open. And so I'm enforcing policies from the platform side, right? Where we're essentially putting guardrails in place so that, yeah, users can deploy things, but it's done in a way that adheres to our organizational policies. All right, so that is a overview of Crossplane. I hope that you gained some information. Crossplane is a fairly large platform, and so there's plenty more to learn about Crossplane. But hopefully that gets you started on the path to using it, adopting it, trying it out. One of those things, or all the above. I just want to thank you for your time. If little plug for RxM, we do offer classes on Crossplane, both from the platform perspective and the user perspective. So hit us up at rxm.com if you're looking for learning on Crossplane or need to train your team. Thanks, everybody.